outcome is not a guarantee at all, and it's not in your hands. And if you constantly tell children that it is the outcome that is directly associated with their capability, then if they don't achieve outcome, they're going to question their capability in its entirety.
Welcome to another edition of ContraMinds. In this episode, we have a very distinguished guest, one of India's foremost neuroscientists, Professor Vidita Vaidya. Professor Vidita Vaidya teaches at the Tata Institute of Fundamental Research, Mumbai. Professor Vidita Vaidya received her undergraduate degree from St. Xavier's College in Life Sciences and Biochemistry. She obtained her doctoral degree in neuroscience from Yale University. Her postdoctoral work was done at the Karolinska Institute in Sweden and at the University of Oxford, UK. She received the prestigious Shanti Swarup Bhatnagar Prize in 2015, which is one of India's foremost awards in the science and technology category. Over to my conversation with Professor Vidita Vaidya. Thank you, Professor Vidita Vaidya, for taking time and joining me in my conversation today.
Thanks, Swami. I look forward to our chat.
I'm quite amazed with the body of work and research that you have done, especially in the neurocircuitry of emotion and the impact of the circuits with respect to depression and things like that. I wanted to first, before talking about all that, first talk to you about your early years. Your parents are also clinical scientists. They've been a big motivation for you. Talk to me about that.
Yeah, so I grew up in Goregaon on a research center campus. In those days, there really wasn't, we're talking about the 1970s, and there was R.A. Mill Colony, there was Sibagaigi campus in Goregaon, and there really wasn't much else. There was Film City also sort of around the corner, but it was pretty green and lush and a remarkably beautiful part of Bombay city. And it was a research center campus that I grew up on. So I was surrounded by a lot of research scientists, chemists, biologists, physiologists, pharmacologists, and it was a medical research, sort of pharmacological drug discovery research center campus, but it was a rather sort of a, in that sense, a very idyllic existence growing up in a city like Mumbai when you had that degree of greenery and, so many trees and plants and animals, and we actually had like panthers sometimes would wander in from across just the Sanjay Gandhi National Park, so it was not unheard of to be told, okay, please be careful this week because, we've had a few sightings. That was not at all unusual. So it was a rather, not an urban childhood in the classical sense. So this is where I grew up, and my parents, my mother and father are both MD PhDs. My father is a clinical pharmacologist. My mother is an endocrinologist. So, but the household, because my grandparents lived with us as well. So it was a joint family, and my grandfather is a freedom fighter who went to jail with Gandhiji, was an MP in Gujarat in the first sort of government post-independence, and is also a novelist and writer. So as a consequence, a lot of the table conversations were quite diverse. It went from, biology to sort of philosophy to literature to, it was a wide spectrum. So yeah, it was a very special childhood that I cherish immensely, no question about it, yeah.
You were also inspired by the work of scientists and educators such as Diane Fossey and Jane Goodall. Tell me a little bit about that.
Yeah, so actually I didn't get introduced to them till a little later. What happened was we used to have, this is the 70s. None of us have television. We don't have air conditioners in our rooms. It's not like the era of kids growing up today, right? So every Wednesday we used to have a seminar series that was held in the campus, beautiful auditorium, which was air conditioned. And as you can see, the air conditioning part was quite an important part for a young child, because the idea of going into that cold room and sitting on the floor while you listen to different talks was rather magical and special. And we used to have talks from many visiting scientists who used to come from all over the world, and they would come and give a broad sort of public lecture. So I remember one lecture. In fact, the rest of the lectures I cannot even remember. We used to also have like Laurel and Hardy and Charlie Chaplin movie screenings in that auditorium. So it was a very, very nice, magical space growing up as a kid because none of us had TVs at home. So this was a treat to get to watch on a big screen and sit in that cold room. But this lecture has just stayed sort of emblazoned in my mind because it was by this couple. Two of them were researching behavior of hippopotamuses in the wild. And they were actually looking at aggressive behavior of male hippopotamuses towards each other. And, when the talk started, initially it was technical, but after that they started playing videos of their travels in Africa. And I think that was my first, oh my gosh, people actually do things like this. And then I read about Diane, about Jane Goodall, and, British Council Library in those days, because that was what our access was. Or you eventually, when you had a sort of, you would borrow tapes, could actually watch David Attenborough watching these. This was just, that was part of that childhood era. So I was absolutely blown away by these women who were doing these incredible things out in the wild.
Professor Vidita Vaidya, you went to Xavier's, then you went to Yale, then you went to the Karolinska Institute, you went to University of Oxford. The learning experience in each of these institutions must be very, very different for you. Talk to me about that.
So I remember when I was in my 11th and 12th, which was actually at Ruia College in Mumbai. And then at that point in time, I was surrounded by everybody who wanted to do either medicine or engineering. And it was really a shock to any of them that I was seriously considering doing a BSc in life science and biochemistry, because that was the sort of last ditch option that anybody took. Nobody wanted to go in for those BSc degrees at that time. And so I remember being told by a lot of people, including, friends of my parents, saying, why would you not take medicine and why would you not choose it? But I remember being very excited about the life science biochemistry program at Xavier's. And it was rather unique and special because it was very broad based. And it's quite different from what we often see today in biotechnology programs, which are very narrow relatively in comparison. So it was a very broad based biology degree. And people from there have gone on to do really a variety of diverse things. So I thoroughly enjoyed my 3 years at Xavier's. And right after that, when it was time to apply to graduate school, I was being very sort of hesitant to apply to the bigger name universities because I felt like, as a young student in India, 3 years here, I have no research experience. Why would any of these bigger universities even potentially look at my application seriously? I didn't want to waste any money on those applications. Those days with our sort of exchange rate, it was actually quite prohibitive to apply. So I told my dad, I'm not going to apply to, the fancier name universities, or even though I found their programs very interesting. And this is the piece of advice that I would love to share with younger people when they are making these sorts of decisions. And my dad said, why don't you at least give them the opportunity to reject you? You have just decided in your own mind to reject yourself and say you're not good enough. But at least give them the option. No, if they reject you, you deal with it. It's okay. It's not the end of the world. But not even applying and not even trying is not a great idea. So because he said that, I literally applied. And I must say I was absolutely gobsmacked and shocked that I got in, right? So I wasn't expecting that. And I also remember my first semester in graduate school where I did feel a little bit thrown in at the deep end, partly because I hadn't done any experimental neuroscience till then at all. And so the learning curve was very, very steep. And it was also different because it was far less content-based and far more conceptual in its manner of, approaching any idea. So you weren't expected to retain information as much as they were very interested in how you would approach a question or how you would resolve or look at a problem. And it took a while to transition from a more traditional, let's try to see how much you can retain in terms of information system to this, more conceptual approach. But once you get excited and find that interesting, you realize that actually information is always at your fingertips. You can find it. It is this other approach, which is how will you look at a problem from a lateral point of view in a unique manner. That is a form of training that you really benefit from. And that's what I thoroughly enjoyed my 5 years at Yale. I also had amazing, amazing mentors. Both my PhD advisor, Ronald Duman, and another mentor, Eric Nestler, Marina Picciotto, and Amy Arnston. These are people who just literally had my back those 5 years. And, it was remarkable to see what mentorship can be when someone invests in you in that manner. And so I think if you ask me what's the educational piece that I most cherish in my entire educational journey, it'll be my 5 years at Yale, because I really met remarkable people and was really blessed to work with some amazing individuals.
How was the learning environment and pedagogy different at Yale versus European schools such as Oxford and the Karolinska Institute?
Yeah, I did, but I think it's also not a direct to direct comparison, because by the time I was in Sweden and at the University of Oxford, I had already graduated with my PhD. So I already had my PhD. So I wasn't really in a classroom situation anymore, even though even in a PhD at Yale, it was just the first 2 years that was more traditional pedagogic learning. The rest of it, you're in the laboratory doing experiments. But the year I spent at Sweden and the 2 years I spent at Oxford, yes, it is quite different. Oxford has a deep tradition, and you see that tradition, it seeps into many, many dimensions. And there are many advantages to it, because there are patterns of learning that are old and have been around for a while. But it also means that you have to fit in more into that environment, whereas the US tended to be more of a melting pot, in a sense that there was just I felt there was a bit more diversity of thought and ways of looking at things. It was just a little bit younger, and the energy of the place was different, definitely. I'm biased. I do definitely say that was my most, cherished educational experience. Sweden, I love the lab. I love the people I was working with. I also really enjoyed the people at Oxford, but Sweden was too cold for me. The dark light fluctuations was enough to do this Bombay girl in. I was like, how can people live with no light for, it was a struggle. I really had a hard time with that cold and that darkness. I can understand that it is a real sort of cultural and, sort of environmental adjustment you actually have to make.
So what brought you to TIFR?
So I wanted to come back home entirely, the entire way. Okay. So there was never a where are you going to live question in my mind at all. I knew that I definitely wanted to come back home. That was clear to me. I knew that I wanted a faculty position, and I wanted to do it at a good institution in the country. And at the time I was applying, which is now 1999, there were just a handful of institutions in the country that did vertebrate neuroscience, of any real significant extent and depth. And so I knew I only had a handful of institutions to apply to. It was not like I was going to apply the length and breadth of the country. And of course, I was biased to Mumbai. I am a Bombay kid. I grew up here. My parents are here. My in-laws are here. We just wanted to come back home to this environment. So it was very clear that this is home. So certainly the focus was very much on coming back to TIFR if I could. I didn't apply to too many other places, but I had a very stated preference that I prefer coming back to Mumbai. And that's what I was lucky to get that position. I think I was just one of the sort of the earliest team of people who began to come back at that point in time.
So where is this interest of study of emotions start, and how did you get into it?
So I remember being interested in behavior. Where do individual differences in behavior arise? And if you ask yourself, what's the organ in the body that produces behavioral states? It's the brain. Now, when you think about behavior, we often think about behavior, we automatically think of our own behavior. And as I sort of went along early years of my PhD, I began to get most interested in the kind of behaviors that could be clubbed under the umbrella of emotional behaviors. And that there are some of these behaviors are very, very conserved. So one example I'll give you is fear. Seen up and down the evolutionary ladder, right? It's a survival instinct. We all need fear as a behavioral response because it prevents us from doing things which are truly foolhardy sometimes, in a sense, right? We learn to fear certain situations, to fear certain contexts. And that's a survival requirement, survival adaptive advantage. So I was interested in the idea that you can actually study the circuits in the brain that can produce fear. But then when fear is wrongly evoked, eventually a failure of these circuits causes anxiety. Now, anxiety could be genuinely because there is a situation that is really anxiogenic. It's genuinely making you anxious. But sometimes you can also have anxiety when there's really no obvious cause. And that I began to find interesting, that these are such adaptive behaviors and we all have them and we require them, and yet they can go completely haywire. And when they go haywire, you have psychiatric disorders like anxiety, depression, obsessive compulsive disorder, panic disorder, schizophrenia. So the spectrum of psychiatric disorders. So it was really early on in my PhD that I knew I wanted to work on the spectrum of behaviors that really, in many ways, are the kind of behaviors that are associated with dysfunction, associated with psychiatric disorders. But I also knew I wanted to do this in rats and mice, right? I wanted to study the circuits. I was not going to be doing this in humans. I actually needed to study the behavioral outputs in animal models. And that requires you cannot ask an animal, are you anxious? That's not an available option, right? What you can do is you can measure how an animal would behave in a situation in which perhaps a fear or a conflict, etc., is generated. And that allows you to do behavioral tasks which you can actually measure their behavior. Yeah. But it was a pretty early interest, in sort of the early part of my PhD.
Tell me a little bit about your lab, the research work that you do there, and specifically the role of serotonin in shaping neurocircuits and stress and control of life experiences.
So if I was to summarize everything that we do in my lab, and there are many different diverse projects, but literally if I had to give like the elevator pitch, right? I meet you in a lift. You ask me, what do you do? I have 2 minutes before you get out of the lift, and I have to give you the elevator pitch. I would say that we are interested in asking how experience shapes these circuits that regulate emotional behavior. Life experience. How does life experience actually modify these circuits and change behavior? So that's one question. And the second question is, how do drugs that are actually used to treat these disorders, so antidepressants, anxiolytics, drugs that are used to reduce anxiety, psychedelic drugs, which are actually hallucinogenic drugs, but can also have very robust behavioral effects, how do they influence these circuits to actually change the behavior? So it's really a two-pronged approach. We're looking at how life experience and how treatments impinge on these circuits to change the way the circuits function, right? Now, there's many ways you can probe this, but central to this is also to ask, are there specific pathways one is particularly interested in? And many people choose their favorite pathway. I am particularly interested in the monoamine serotonin. It's an evolutionarily conserved molecule. Its evolutionary history is greater than 3 billion years ago. So it's really old. It's there from the earliest stages of multicellular organisms. So multicellularity and the presence of serotonin right there at the very earliest stages of archaea, etc. There in mollusks. So it's there long before even neurons appear. It's there long before a nervous system and a brain as we recognize it appears. And the receptors for serotonin don't show up till around 716 million years ago. So that just gives you the but these are evolutionarily old systems, right? And serotonin is, we know, targeted both by life experience and both by drugs that treat depression and anxiety and schizophrenia. So we're very interested in this particular neurotransmitter, how it works, how is it co-opted? In a sense, what we're asking is life experience actually co-opting or modulating this pathway to change the circuits? And drugs, for example, let's take a drug like Prozac, which made Eli Lilly very, very wealthy, but is essentially an antidepressant that has been extensively used. It elevates levels of serotonin in the brain. And so that's the two-pronged approach that we use. But that sort of broadly summarizes most of the work in my lab.
How do you take that research and apply it to real life? You study it on mice and rats. How do you really take the learnings back into the real world?
So we don't. we would define ourselves as fundamental research, basic research biologists. And the sort of work I do is basic behavioral neuropsychopharmacology. But the way you can think about this is a pipeline, right? And there are people working at different levels. So I happen to work with rats and mice. There are people who work with monkeys. There are people who work directly with humans. There are people who work with neurons that are derived from cells and stem cells that are taken from humans and grown in vitro. So you have multiple people in this pipeline. And this pipeline is not such that you're not talking to each other, because the community as a whole is sharing their science collectively with each other. And we are very influenced, not just by work that's done in humans, but also the reverse way. Work done in rodents informs work that is actually then being applied to the human situation. Plus, especially when we work with drugs, some of these are experimental drugs that are not even currently potential therapy-like modules, right? They're not out there as therapies. And that becomes quite interesting to sort of the pipeline of the pharma industry. And so you can then have sort of these collaborations and dialogue with that pipeline as well. And leads get picked up from there to actually go into a more translational mode. So what I think I would say is what we do has translational implications. Does it immediately translate? No, it's dependent on the pipeline to eventually get translated to the human. But that's pretty much how most drug discovery or therapeutic work goes. And very often the application component being people who directly are medical doctors working with patients, or the pharma industry developing a molecule. But the SARS-CoV-2 vaccine is a great example of this. If you actually think about the research that started this vaccine, it started in a very basic research lab at Penn. Right, at UPenn. The mRNA vaccine idea is really coming in initially from a basic science lab, and then it translates. But these things take time. It's 15 years, sometimes it's 10 years, sometimes it's 20 years. So I would say I'm at the very beginning end of that pipeline, not at the other sort of end that actually results in the translation. Yeah.
I saw you talk about the lifestyle disorders being the next biggest reason for causing deaths. And some of your studies of the brain, the emotion, the life experiences are so critical in this lifestyle disorders. Can you talk to me a little bit about that?
Yeah. So if you think about, let's say we were 100 years ago, of course, we wouldn't be having a podcast 100 years back, but let's imagine we were talking to each other 100 years ago, right? About 100 years ago, we would have been talking about, oh no, there's going to be, that we have to, at that point in time, we'd have been talking about Spanish influenza. So we'd be talking about, it wouldn't be unusual to have heard about a plague epidemic somewhere. It would not be unusual at all to be talking about cholera and dysentery. And, if you look at infectious diseases and the infectious disease burden, and if you look at the way people were dying in the first sort of 50 years from 1900 to 1950, if you look at that window, you can actually see that life expectancy 50, 60 was a very great life expectancy. People are like, oh, that's really good. Somebody's lived a full life. Now we will say, oh no, the person died rather young because something dramatically changed. And it's really a remarkable biomedical intervention. So if you just think about the advent of antibiotics, as simple as that, right? The discovery of penicillin, the application of antibiotics to bacterial infections, which could kill you in the past. But now we don't even think about it. We will say, oh yeah, this can be treated. So absolutely, biomedical science handled a very large chunk of infectious diseases and took it off the table. We will never think about somebody getting polio anymore. And yet it was a serious, we know, at least our age group knows people who had polio. But our children will not even identify with the idea of somebody who had polio because it's not part of their vocabulary anymore. Smallpox, again, we saw people with smallpox lesions. Our generation has grown up with that. Their generation has no clue what a smallpox lesion looks like. It just isn't even in there because the vaccine, took care of it and the virus is eliminated, doesn't exist anywhere on the globe. So when you think about that and now you say, okay, 100 years later, today, what are we talking about? We're talking about heart attack. We're talking about stroke. We're talking about cancer. We're talking about chronic disorders that emerge very often in a slow manner And our cumulative burden may be a component of it being stress, but also a variety of other components of lifestyle. By the way, psychiatric disorders fall into that list in terms of health burden. By 2020, the WHO estimate was it was going to be one of the second leading causes of serious morbidity, right? So it is true. I mean, anxiety, depression, schizophrenia, OCD, serious disease burden there. And so in a sense, what you can say our work does is because we are interested in how life experiences change the brain, and we are also interested in how life experiences change our ability to handle and respond to stress in particular, we are really looking at what makes you vulnerable and what makes you resilient. Because it turns out that it's not as though, yes, there is a component of genetic capability, both for vulnerability and for resilience. But there's a massive, huge component of environment that will determine whether you will be able to buffer stress or you will be excessively vulnerable to it. And that's what we're very interested in asking. Why does this happen? Right? We work with genetically inbred mouse models. We are reducing genetic variability. So we're really looking at the big impact of environment, and we can see a huge impact of environment with a disproportionate influence of early environment. Not the environment you see in adulthood, but the kind of environment you saw as a baby or as an adolescent. That window seems to be most critical.
So talk to me a little bit about that, the early life experiences. In fact, one of your research studies talks about really, using that study to talk about the first 10, 15 years of how this experience has lifetime implications on how you handle emotion, how do you handle stress, and how the importance of care has an impact on the brain.
Right. So, here's a good example of how we can get inspired by what is known clinically, and then there's a back and forth between the preclinical and the clinical. So it's not surprising, and lots of epidemiological studies have shown that if you look for a common risk factor, what are common risk factors for anxiety, depression, schizophrenia, substance abuse? Let's look for common risk factors. One of the most common risk factors is early life trauma and early life adversity, early life stress. Okay, this is common. It doesn't matter which psychiatric disorder you're looking at, all of them hold in common this early life trauma like history. It's a risk factor. It's not a guarantee. So don't walk away thinking that everyone who goes through trauma is automatically going to go ahead and get some psychiatric disorder. Not at all. But what it does tell you is that your risk enhances substantially when you have this early life adversity. So this is known clinically for quite some time. And the community of people who are like me, right, who are basic neurobiologists, have been wanting to understand what actually changes in the brain. What's really changing when these animals are going through altered sort of life history in the early window? So we use a model of neglect, right? Now, what do I mean by neglect? The animals are not nutritionally deprived. They're getting their food, so they're putting on weight, etc. All that is happening. But the amount of nurture they actually see, and you can actually measure the number of nursing bouts, the number of times the dam sits on top of the pups and, licks them and grooms them and nurtures sort of stimulation, which is tactile, right? So touch-related stimulation. And that seems to be extremely critical. So if that gets fragmented and the quality of that deteriorates, and please be aware that the species I work with, it is largely the mother. But if you take another species, it is the mother and the father, right? So it's both. And when you move to primates who are much closer to us, then it's even more complex. It's not just mother and father. It's mother, father, aunts, uncles. There's a community. So there's a nurturing community that comes to play. It's not just one individual. But for the species I work with, it really is much more just the mother. It's just that equation. And if the quality of care deteriorates, then you look at these. So now then you let these animals grow up and you run them on a battery of behavioral tasks. And what you will find is they show perturbed fear responses. Their stress hormonal pathways have gone haywire. Their ability to control their stress response has gone haywire. The hormonal stress response, as well as other signatures of stress responses. They show changes in their gut And in fact, it's a model of irritable bowel syndrome as well, telling you that it's not just the brain. There are broader effects. There can be effects seen in the gut, in the periphery. Their immune system responses are not normal. So what has happened is a consequence of this perturbation, which was relatively not so severe. It's just that there was not perhaps the best quality of nurture in that early window. You will see very persistent effects. In fact, we have looked out till 18 months, which is actually a middle-aged rat or a middle-aged mouse. That's really quite old, right? For the lifespan of rats and mice is 2.5 years. So this 18 months is pretty old. We're looking at the older end. And you can see that these effects are so clear-cut that 18 months later, when you're looking at the brain or you're looking at behavior, you can say, aha, these animals had a disrupted early stress history. So the sort of the marks associated with this persist almost across the entire lifespan. And that is a little unnerving in a sense to think that early window, because you can do stress in adulthood. You can take an adult animal and give it a variety of stressors, and the effects are usually short-lived. Yeah, the animal goes to stress, but after the stress stops, it comes back to normal. It more often than not, it reverts right back to its baseline. But not when the stress is when the animals are in this window called a critical period. And that's why it's so interesting, because even humans have critical periods. And perhaps the best way I can demonstrate a critical period is if I tell you, Swami, I think you should go learn 2-3 new languages, right? You will tell me, Vidita, no, this is not a great idea. I will try very hard, but I'm very unlikely to learn 3-4 new languages. Maybe I take your grandchild, okay? If you have a grandchild or you have a young niece or nephew, someone who's under 10. And I tell this kid, you know what? I want you to play around with 4-5 different families, all of whom speak different languages. I bet you after some time, this child will start getting fluency in a variety of languages. There is a reason why. There is a critical period for language learning. And that is that early first 10 years. So if you have learned, I bet you're bilingual, right, Swami? You speak multiple languages. Most
Absolutely.
of us Indians are bilingual, multilingual. And we find it very easy to switch from one language to another because we think in many languages. And this multilinguality is actually a really good plasticity advantage for the brain. But if we were to try and acquire a whole bunch of new languages, we will struggle. It will not be straightforward. And so just like there is a critical period for learning something, there are also critical periods for stress responses. In a sense, the brain is predicting the kind of environment it will see when this animal becomes an adult. So the animal sees a very stressful environment. It's almost as though the system is saying, oh my God, I'm going to always see a lot of stress. So I better have a hyper vigilant, hyper primed, excessively active stress response pathway. And then what happens is the following. So imagine a situation. I'll give you an example. So this system is beautiful because it evolved. Our stress response systems evolved beautifully when we were wandering around in the savannah, etc. Right? Imagine that our ancestors were out there. You need to run away if somebody's trying to catch you. And so certainly the stress response pathway is very useful then. You need to, mobilize glucose to your muscle. You need to switch off digestion, switch off reproduction, really reorient your system and hopefully you escape. Even if you're trying to catch your food and your food is something that is moving, it could be an animal, then to run after it and catch it and all, again, is a stress response path. But these are all short-lived, quick, tiny, short duration. Either you run away, you catch it, something happens, it terminates. The system is beautifully designed for that. Now, why are we switching it on? Let's say you have a fight with your boss, or rather you have a disagreement with your boss. You come home. Now, the weekend is there. You have a chance to play with your child. You have a chance to do something else. Maybe you can watch a movie. Maybe you can cook a nice meal. But your mind is constantly preoccupied with this argument you had on Friday. And you are just destroying your current moment thinking about this. But you know what your body is doing? Your body is secreting the exact same hormones it would have secreted if you were running away from a tiger or running after something. So stress response pathway is conserved. It hasn't changed. Except this is going to go on constantly.
And if you have to work with this person for months and months, you are going to bathe your body with sustained stress hormones for long periods of time. What seems to be true is individuals who had early adversity have particularly higher degree of challenge modulating their stress response and controlling it and shutting it off. So as important as it is to switch on a stress response, it's equally important to switch it off. So that was a very long-winded answer, but hopefully that gives you a sense of why those early windows matter so much.
Very interesting. Most importantly, the early life syndrome that you spoke about has a huge implication on the entire life of how somebody copes with stress. It could be your family, it could be your work-related stress. So what are the best ways of building stress coping pathways? What are the frameworks and the architecture? You have written about the stress architecture itself. So what are the stress coping pathways one can build, because the adversity is long done and gone? How do you really build your stress control pathways?
So I'm first going to talk about it in terms of prevention, and then we're going to talk in terms of treatment, because prevention is going to do way more better than any treatment is going to. And I'm going to just give you the bad news that prevention is really the best way out. Why do I say this? Because if you think about our own country, we are a lopsided country in terms of youth. We have a young population. We're a young country. So if you look at our pyramid, we have a really big, wide base. We have so many people under the age of 25. Till 25, your prefrontal cortex there's a fair bit of really protracted development still going on in terms of organizing the circuitry in the brain, right? But the first window, the really critical first window, is the first 10 years. What you do right in that first 10 years is going to hold you in good stead for the next 70, right? Now, yes, you can attempt to try to repair the consequences of what went wrong in the first 10, and I'll come to that. But I would say as a society, as a country with this sort of a young population, our first goal should be to provide for that pyramid being protected by being given the right things in that window. Then the absolute basics are, of course, nutrition, education, access to healthcare, right? 3 pillars. I'm not even going to, I know I'm talking to a slightly more privileged audience. The idea is without that, it is almost pointless having these discussions. If nutrition is not on the table, then really what are we talking about? Nurture and care and all of that is, yes, it's wonderful, but nutrition is a key building block, and it's absolutely essential for the brain to develop appropriately. So poverty is itself a massive stress. It is a massive stress and a massive disadvantage in some ways. And so as a country, when we look at that window, when you think about midday meal programs, when you think about providing government-based educational programs and access to healthcare, etc., it's a critical place to invest. Because you can build all the roads and you can build all the infrastructure. If you do not build your human capital, you will have all that, but you will not have what it really requires. That's what's going to shape our country going forward, right? So really investment in nutrition, investment in healthcare, and investment in education. These are the 3 pillars. And we have to do that right. And that's why I'm saying prevention is the bigger piece. We need to get public healthcare in place. We need to get basic governmental education so that right to education is available for all children of this country. And we have to provide nutrition of a certain caliber and quality when there is challenges in terms of being able to access that kind of nutrition. It has to come through government-aided programs, and that has to be an investment area. I know we talk about defense as an investment area, but this, in my opinion, would be the place to really look at long-term, that you'll reap the benefits if you do this investment right. And you will reap the benefits going forward for decades and decades if you do this right. So to me, that's the first piece. Now, let's say those pillars are in place. If those pillars are in place, that means a child who has access to nutrition, access to healthcare, has got their vaccines, has the basic things and pillars are in place. What is the next level? Now I'm talking about psychological. Those were physical stresses and physical issues, but psychological stressors. If there are stressors along the lines that are associated with performance, continuous requirement to get people to get into kindergarten, first standard, 10th standard exams, if you look at the burden you're putting on under 10, under 15-year-olds, I would give you an example of the IIT entrance exam. If for 2 years you're putting people into coaching classes with a frenetic pace, you're just killing creativity. I'm not sure you will end up with a ton of creative enterprise at the end of it. You may have a bunch of people who have been trained to perform, but you have lost all creative advantage in the process. So I think it's really interesting that we have a national education policy. Much of it has really interesting things in place. But our problem in our country has never been our policies. It has always been our implementation. So the question is, that's going to be the critical part. Right now, these are broader ideas at the level of government, state government, institutions, etc. What about for the individual? What about for you, me, aunts, uncles, grandparents, etc.? I'll tell you something that goes really a long way. Every child needs somebody who believes in them unconditionally, just unconditionally believes in their true potential to flower at something or the other, whatever that may be, right? So you need people in your corner who are backing you, because yes, stresses will come, but if you have a robust sense of your self-worth, it really does protect. And now I'm using a major extrapolation from what we do in rodents and rats and mice models, but I'll tell you something. There's enough data to indicate that high quality nurture, even in rats and mice, right? You can actually look at high quality nurture. And you look at these animals when they become adult, they're far less likely to show anxiety and despair-like behavior. Their fear responses are beautifully modulated. They show altered cognitive ability, so that happens. Their inflammatory responses are far tighter, regulated, and controlled. They really have a massive fighting advantage. Now, how much of this is true for humans? There's strong reason to believe it is indeed true. From work done by psychologists, work done by psychiatrists, there are many things each of us can do. Let's say you work you live in a building in a society, and you build all the parking lots and you leave no place for your children to play. So you have 3 cars per building and they're all parked. And then if kids go down and play with a cricket ball and they break a window or they break a glass, you yell at them because you've essentially taken away all free play, all room for stress busters. I think there's a role for each of us to play as a citizen, as a parent, as an aunt, uncle, friend. I need more nurturing environments to that under 10, under 15-year-old pool. And to do it consciously. So it's not just something you default to, but you're consciously asking yourself, what am I doing as a citizen to contribute to that age group that I have contact with, right? So I do think there is a role for each of us to play in that window. And the consequences of this will be deep and long lasting because, like I said, when you move to primates away from rodents, it moves to a society. It's no longer mother and father. Much the same way for the human, right? It is aunt, uncle, mother, father, siblings, grandparents, teachers, building auntie, somebody down the road. It's your sports teacher. It is multiple people. And each of those people is bringing something to bear. So it's a much more complex situation. But the data strongly indicate that quality of care, nurture, a minimal stressful environment. And when I say a minimal stressful environment, but don't do it in a manner which, makes the child totally lose their sense of fun and play in any learning process. So, yeah.
So India is a large middle class population, and we know the kind of stress the kids go through, given the fact that, in fact, you said early in our chat that you either do medical or engineering and, you put them through that kind of stress. At the same time, you also talked about the conceptual learning that AIL gave you. So right. How do you build that nurture environment in a middle class environment in India where it's so competitive out there? it's a real issue that I see today, because when somebody does not get into IIT, somebody does not go to Harvard, somebody does not join Columbia, you pretty much then start saying that, oh, you're not successful. So how does the brain really get affected by all this?
Right. So I think it's critical to remember that you cannot be outcome oriented, you have to be process oriented. So if you start off by saying, my goal post is to go to X university or Y university, you have already decided that that's your goal. And it may or may not happen. There's a very strong possibility that when thousands and hundreds and lakhs of children are applying, so, it's a difference between half a mark and 1 mark and 2 marks, and that's going to determine whether you get in or not. It's not your capability that's being tested. It's the luck on that particular day, whether, you were distracted by a helicopter that was flying outside. It's a bunch of arbitrary reasons that can switch, one situation to the other. It's really not testing for capability. It's testing for some sort of performance under a very controlled kind of pressure environment. I understand that we think about outcomes first because we want as a community to ensure that our children will be secure, right? We are saying, I want my child to have a stable job. I want them to be able to do well, raise a family. So with each generation, you're looking for something to improve in the next generation. Now, part of the problem with being so outcome oriented is the outcome is not a guarantee at all, and it's not in your hands. And if you constantly tell children that it is the outcome that is directly associated with their capability, then if they don't achieve outcome, they're going to question their capability in its entirety. Whereas if you say process-oriented, which is what? Child wants to be an engineer. Are you telling me that the child cannot be an engineer? They don't. We know lots of engineers in the country. Does everyone have to go to IIT Kanpur or IIT Bombay? Not. In fact, many of them go to IIT managers in a finance, right? They're not doing any engineering, right? So there really is. So I think the question reframed to one is, can you focus on the process for the child? The outcome is a byproduct. Okay, the outcome is a consequence of having done the process. The process is learning, an engagement with learning, a desire to enjoy the learning process, and there's no question that you tend to do better if you enjoy what you're learning. If you're doing something that you're miserable at, it is very likely the outcome will also not be great. But if you're doing something that you really enjoy, you will do it more. There's no question that practice does help the brain. I mean, performance is associated with repetitive practice as well. But you are not going to do repetitive practice if you hate what you're doing. So I think a mindset shift has to happen in our large Indian parental mindset, which is do not focus so much on the outcome. Mera beta engineer banega, meri beti doctor banegi. This is the goal. You have already set the goal, and they don't achieve that goal, you're going to be miserable, they are going to be miserable, it's not worth it. But if you say, my child is going to learn, and my child is going to excel at whatever they learn, and I'm going to provide them the opportunities to excel in whatever they really enjoy, it takes away the security blanket of some notional outcome, which is not guaranteed anyway. Right? There's no guarantees that outcome is going to happen. But the process, if you do, and you believe in the process, eventually some good outcome will come out of it. I mean, the child will do, whatever they are happy at. And now this is really hard to sort of fix, because very often we still have people come to us for interviews and the question will be asked, but what is the scope of doing a PhD? We cannot answer that question. How do you measure scope? Right? It's not we can say, well, if the person loves what they're doing, they're going to have an enjoyable career. But there are questions like how much are you going to earn? Are you going to be able to raise a family? Are you going to be able to do X? Are you going to be able to do... And these are all very valid, genuine concerns, but they cannot become the sum total of everything. They have to be sort of parked at a slightly lower level. Primary interest has to be focused on first.
So you talked about preventive. The reason I'm focusing on that is we have a very large working population. They've already gone through the education. They've already gone through their schooling, and now they are in a job. Maybe the early stages of the brain structure, the growth of those neurons in the brain have had some impact. How do you really cope up with this kind of a lower stress coping mechanism that they might have built with, and what should they be doing, because they have another 40-50 years to take care of their life?
Right. So essentially you're asking me, is there a way to train your brain to become more resilient, to become better at handling stress, right? Yes, there is. Like many things, you can exercise and build a muscle. Much the same way, you can train your brain to handle certain things better. No question about it, right? The easiest answer is to see if you can remove the stress. And in some cases, it is doable. In some cases, not doable at all, right? So if it is a sustained stress and it's a severe sustained stress, and you know that there is a way to avoid that severe stressor, then one tries to set up a situation where one removes oneself from that stress if one can, if it's a severe psychological or physical stress. But that is a rare option, and that's not something that's always available at all, right? So then what do you do when you have to live with the stress, in a sense? So in a sense, the question is, how do you get your mind to not focus on that stress non-stop? Let's say that it could be, for example, a very terrible relationship in your work, but you cannot quit your job, because at the end of the day, that job is bringing money to the table and you support your family with that job. So quitting the job is not an option. You are not able to change the environment. You're not able to change the people around you, but you have to now, only thing that is in your control is modulating your response, right? So the first step is to try to ask how often the stress continues to impact you after the event is closed out. So even if you have a nasty interaction with someone, usually it's short-lived, 5 minutes, 10 minutes, but how much do you ruminate over it? If you ruminate over it for 24 hours, 48 hours, 72 hours, that event which is restricted to 10 minutes has become a 72-hour long event, right? So that's the first sort of thing you want to target. You may not be able to bring it down from 72 hours to 1 hour and 10 minutes, but you can start by saying, I'm going to find windows in which I can switch my mind off this event.
Walk me through the process of rumination and how it affects the brain.
So the brain is an interesting structure. It does something called pattern separation and pattern generalization. Now I'll tell you what pattern separation is, okay? So let's say I am an employee in a company and I go to a particular office and I'm at the branch office, head office, and I have a very nasty interaction with my superior at this office, and becomes a very stressful environment for me. So now this is a pattern I associate with this environment. I generally think that, okay, when I go to the head office, I'm going to have an unpleasant reaction. Now I am posted to a new office, let's say in Andheri. Okay, so I have now no longer got to go to the head office. I'm going to the new Andheri office. I can pattern separate, which would be the right thing to do, and say, this is a new environment. It's totally fresh. It may be wonderful. And if you pattern separate successfully and it turns out to be a better environment, you will not generalize the trauma of that environment to the new environment. But more often than not, what happens, and this happens quite routinely, is you pattern generalize. मेरा पहला बॉस ऐसा ही था, अभी ये दूसरा वाला भी वैसा ही होगा, right? I'm giving you the sort of the lingua franca of how we say it to each other. This is how it was, now it's going to be like this. ऐसा ही होने वाला है, right? We say this. Why do we say this? We're generalizing something that has happened in one context to a totally new context. It turns out that there's a part of the brain called the hippocampus, which is very involved in learning and memory, which is essential for this kind of pattern separation-like event. And this part of the brain continues to make new neurons throughout life, right? And the more new neurons you make, the better you are at pattern separate. So in a sense, think about it as a muscle, right? I mean, your ability to lift a weight will be better if you have a good muscle. So much the same way, if your hippocampus is endowed with good, healthy newborn neurons and nicely functioning networks, you are likely to do pattern separation much more effectively. So you pattern generalize to all situations, all contexts, all environments. But if you pattern separate, so now what I'm trying to tell you is what you want to become, Swami, is a pattern separator, a really effective pattern separator. So, okay, if you have to do this in terms of how do you change your brain to become a better pattern separator, one of the things that we know that does better pattern separation is actually making more newborn neurons within the hippocampus. And what increases newborn neuron formation? And we know this from rats, we know this from mice, we know this from monkeys, we know this from birds. What actually increases the production of newborn neurons? Two things I'll tell you. Many things do, but two. One is learning something new. Okay, learning. The other is exercise, voluntary exercise. Both of these two things, they help cognition and learning, but they also help in pattern separation, right? So in a sense, if we are to extrapolate, we don't know this is exactly true for humans, but we're extrapolating from data that we know in many other systems. I would say that amongst the most potent indicators of allowing resilience to come in is to learn something new, something that challenges your brain, or to exercise routinely, regularly, with a diversity of varied exercises that are enjoyable to you.
So when the growth of neurons happen, what happens to the brain and therefore your stress coping pathways, and what happens to your own behavior and your ability to manage the environment?
So these new neurons integrate into what are called stable networks in the hippocampus. They are born. They migrate short distances, they send out dendrites, they send out their processes, they send out axons, and they inherently increase what's called plasticity, the ability to respond to new change, right? So it's a new change that's happening. The hippocampus is a top-down regulator of the stress hormone pathway. So what I was talking about before, cortisol, which is produced in your body when you are highly stressed. It's a cholesterol-derived hormone, and your body makes a ton of it when you are under stress. Now, why does this matter? Let's take the example I told you. You had a bad fight with your boss. It lasted for 10 minutes. You are worrying about it 1 week later. You in your body with cortisol for way longer hours than that actual event. And your body thinks you're under chronic stress, right? So you're actually under a lot of chronic stress. If you can switch it off effectively and quickly, you will terminate and reduce the time. The stress will still be stressful, but it will not be stressful for so long. And the hippocampus is actually one of the key structures in the brain that actually drives the top-down regulation of this pathway and switches off the stress response.
Okay. You also do a lot of study around antidepressants and their impact on the brain. Is having antidepressants, does it have a permanent impact, or is it something that is probably temporary? How does it affect the brain? And today I see a lot of prescriptions of antidepressants and people taking antidepressants for stress coping mechanisms. What do you see of that and the impact on the brain?
Right. So most currently prescribed antidepressants, levels of monoamines, these are neurotransmitters, serotonin, norepinephrine, and to a certain degree, but a lesser extent, dopamine. But it's really serotonin and norepinephrine. They do this by blocking the reuptake of this neurotransmitter back into the presynaptic neuron. So what you end up doing is, essentially think about it like this. You don't have enough serotonin or norepinephrine, or it's not working normally. That's a very loose-handed way of saying what might be going wrong in depression. Certainly doesn't tell you the whole story, but certainly these pathways seem to be dysfunctional in depressed individuals. What you're doing is artificially going in and allowing more serotonin and norepinephrine to accumulate in the brain. You can do this in other ways besides doing it with drugs. You can do it with cognitive behavior therapy, which also, by the way, is highly effective at the milder scale of depression. You can do this with exercise, which will also increase serotonin and norepinephrine in the brain. And certainly at the milder end, when we're talking about mild dysthymia, or at the milder end, it's these other interventions that could be very, very effective, right? But when you're talking about somebody who has to then visit a psychiatrist, they will likely prescribe them drugs if they believe that this is a sustained long-lasting pattern that is disrupting their ability to do normal functioning of their life. And if they have suicidal ideation or they are incapable of really performing their basic normal functioning in life. And they will prescribe this, but they will also likely prescribe behavior therapy. They will suggest a bunch of things. And the person will do that for a period of time. And certainly what antidepressants do create an effective change in the brain. It really depends on what the environment is like as well. I mean, if you've been able to give the person either effective behavioral, so using cognitive behavior therapy, you've given the person the tools they need to cope. They may be able to handle the environment better. Or for whatever reason, the environment has changed to a certain degree. They may be able to show recovery, but very often are recurring disorders with recurring episodes of depression, which often last for longish periods of time, and the person may go on, off, and antidepressants, off and on for long stretches, and that's not unheard of, and that happens quite commonly.
You talked about the importance of learning. How do you do continuous learning?
Constantly reading people's papers and reading interesting discoveries. I mean, by definition is really learning new things every single day, right? So, I mean, that's one of the things I love the most about what I do, which is that I get to read about exciting studies which are being made all over the world about the brain. And it's not just about the neurocircuitry of emotion. I'm interested in, broad neuroscience and broad biology. So reading about those discoveries and learning about them and, reading the publications, I mean, that's a form of learning. But I like to push myself out of my comfort zone, right? I like to learn things that I don't think I would be able to do. So across the pandemic, I took a acrylic oil painting course. And I did two sessions of six weeks, and I don't know how to paint. Okay, so it's not like I've held a brush and I know how to do acrylic painting, and I don't know any of it. But I did these online courses because what we also know from research from so many groups over the world is that if you keep repeating and doing the things that you're already good at, and you will just get better at them, yes, but it's not really challenging you. I mean, it really doesn't challenge you because you're defaulting to things that you can do easily. So
does it affect the brain in any way when you do something like an acrylic painting? What happens to the brain? So the new neurons get generated, is it?
I don't know if new neurons got generated in my brain when I was doing acrylic painting, but I can tell you that it was a remarkable stress buster. It really was. Because for the 45 minutes, I was listening to my instructor telling me, okay, now mix this paint with titanium white color, mix this paint with a sienna brown. It was like therapy because I was sitting and mixing colors. And when I was painting, I wasn't thinking about anything else. My mind was utterly present in that moment with that. I was present, right? And that's in some sense, that's what they talk about mindful meditation as well, which is being present in that moment and not allowing. So I found it remarkably wonderful. I don't know what I learned, or I enjoyed painting very much, and I will take another class happily anytime. But I would say, learning a new musical instrument, taking on a new hobby, learning a new language. Oh my God, that's a serious challenge. I mean, you really stretch yourself when you do things like that, right? Learning something new, something that you haven't done. I mean, people have been making, during the pandemic, people have been baking all kinds of things, and people have been cooking and sending food and friends, and people are doing so many different things, right? So sometimes it's about learning a new skill. Maybe it's embroidery, maybe it's crochet, maybe it's music, you pick up a new instrument, variety of things. But I would say pushing the boundaries to go outside of your comfort zone is critical. It cannot be just within your comfort zone. And if your comfort zone is a little too narrow, push the boundaries a little bit further. Push yourself out. So for example, let's say you want to learn how to dance, right? Now, that requires motor movements and muscle movements that your body is not used to making. It will require a whole reorientation of your sort of neural circuitry to allow you to become adept at dance. And that's pushing your circuits to do something quite different. So I think the key part is not just learning, but what you are learning and whether you're really challenging yourself by pushing yourself out of your comfort zone.
Great. How do you see neuroscience changing over the next decade or more? What do you think are going to be the key trends you're seeing in neuroscience, and how will it impact the research that you do? How will it impact society at large?
So I'll start by saying that in the last 20 years, we are witnessing a huge revolution in neuroscience. I mean, so let's put it this way. Is it because we're asking questions that have never been asked by anybody before? No, not really. Okay. Many times the questions have been there for a long time. We just didn't have the tools to ask them really effectively. We were sort of hamstrung on the kind of tools and technology we had to really probe the brain. In the last 20 years, the sort of tools and technology that has come to play, we have tools that allow us to go in and actually switch on a population of neurons. We have tools that allow us to switch off a population of neurons. We have tools that allow us to say, okay, I'm very interested in a pathway that goes from the ventral hippocampus to the basolateral amygdala. I just want to activate or inhibit this pathway and see what it does to behavior, see what it does to function. Now, where is the impact of this, and when is it going to translate for people, the lay person who's waiting to see the impact come in, right? I think it's going to be huge in the next 15, 20, 30 years. I'll give you an example. Now, let's say spinal cord injury, right? Very common, happens often in young people who have an accident, even someone who's driving a motorcycle. You get paralyzed because the spinal cord is resected or injured really badly. There's nothing wrong with the brain, nothing wrong with the muscles, just that the wires, in a sense, the communication pathway that connects are gone. So you can't control. The individual is paralyzed at the prime window of their life. We don't have therapies for this currently. I mean, we have all sorts of ideas and potential things in the pipeline, but nothing that's yet led to a therapeutic breakthrough, right? But already in the basic neuroscience realm, we have seen that there are ways to bypass this, such that you can actually control the neurons in the spinal cord that directly regulate the muscles. And so despite a spinal resection, you can see the mouse start walking again, even start doing movement again. Now, this is huge. This is mind-blowing, right? Because this has not happened before. So the kind of therapeutic breakthroughs that are happening in basic neuroscience will take some time to translate, but they are unprecedented and they are immensely exciting. And I hope that as a whole, the public continues to be supportive of basic research, because it takes time. These things require patience. They are not going to be wave a wand and fix them. There's so much we still don't understand about the brain. And so I'm immensely hopeful, terribly optimistic. And I would say to young people who are thinking about both a career as well as thinking about the outcomes they will see in their lifespan, I would say engage with neuroscience. If you want to be a neuroscientist, do it. This is the time to be a neuroscientist. It's one of the most exciting fields. And I mean, there isn't a day that goes by where you don't have an oh wow moment, and you're listening to something or you're reading something and your mind is blown because you're thinking, that is a pretty phenomenal finding, right? And that is an addictive state of mind to have the sort of opportunity to see cutting edge science. And I really hope there are people who will think about neuroscience as a career. But let's say you don't even think about neuroscience as a career. I would say engage with, there's so much popular information out there, which the neuroscience community has put out there, either through popular reading or through books by Oliver Sacks, books by many others. Engage with them, because you will, in the next 30 years, definitely start seeing incredible things showing up. I'm not even talking about brain-machine interface, right? That is another, people who are doing AI and computer science and are cross-talking to people in the neuroscience community. Brain-machine interface is also going to be a remarkable area in which we will see applications rolling out into the market, out into the commonplace over a short period of time.
Great. I want to end this conversation with a question which I normally ask my guests. If you were to write a letter to a 10-year-old self, to yourself today, what would be the 3 pieces of advice you would give her?
I would say to my 10-year-old version of myself, don't ever let anybody else condition on your dreams. That would be the first one. 2, always remember to enjoy learning no matter where it comes from, because that is lifelong and is positively the most rewarding. It will help you cope with whatever comes your way in your life. And take your work seriously, but don't take yourself seriously. So enjoy your work, take it seriously, but always have a sense of humor to be able to laugh at situations that arise, and don't take yourself too seriously.
Thanks a lot, Professor Vidita Vaidya. It was really brilliant talking to you. I really learned a lot of stuff about the brain, the kind of emotions that the brain creates with its neurocircuitry, and I really enjoyed and I learned a lot through this conversation. Thanks a lot for your time.
Thank you, Swami. I thoroughly enjoyed talking to you too, and you took me to many sort of ideas and places, and how does one take insights that come from a laboratory environment to the real life, actual real world scenario, and I enjoyed it very much too.
Thanks a lot.